Hello everyone, I am Viti Patel. We are going to see redundant functional dependencies in this tutorial. In this tutorial, we will see what redundant functional dependencies and how they can be removed from the functional dependencies. Redundant functional dependencies means we can derive other functional dependencies from given functional dependency. Redundancy means having multiple copies of the same data in the database. This problem arises when a database is not normalized. Problem caused due to redundancies are insertion anomalies, deletion anomalies, and updation anomalies. Through various steps, we can detect redundancy in functional dependency and we can remove it. To understand how to detect and remove redundant functional dependency, let's take an example. We have relation R having attribute A, B, C and D, and attribute set F has functional dependencies which are B determines A, AD determines BC and C determines ABD. Suppose we have a functional dependency X determined Y, where X and Y are set of attributes, not a single attribute. So, there may be redundancy in left hand side means X is redundant, or there may be a redundancy in right hand side means Y is redundant, or full functional dependency is redundant. We start checking from the right hand side attributes. For that, we decompose the relation from right hand side. We cannot decompose the dependency from left hand side. Why it is not done? For that, suppose we have dependencies called AB determines C. In the dependency, if we decompose from left hand side, then we get A determines C and B determines C, which is not possible. So, let's start with decomposing the relation from right hand side. Next step is finding closure set for individual dependency. For that, take the dependency B determines A. Closure set of B is BA. Now, without considering this dependency, we get closure set of B is B, which is not same as above. So, dependency B determines A is not redundant. Now, next dependency is AD determines B. Find the closure set of AD. We get A, D, B and C from the dependency. From C, we get A, B and D, but they are already present in the closure set, so we are not including them again. Now, find the closure set of AD without including AD determines B dependency. We get A, D, C, and from C, we get A, B and D. We include only B because A and D are already present in the closure set. Here, order of attributes does not matter. We get same attributes without AD determines B dependency, so it is redundant. So we exclude it. Now take next dependency, which is AD determines C. In the closure set of AD, we get attributes A, D, C and B. Here B determines from the dependency C determines B. Now without AD determines C dependency, if we find the closure set, then we get AD only. We cannot include B because we have already excluded AD determines B dependency. We get two different attributes with and without AD determines C dependency, so we cannot exclude this dependency. Next dependency is C determines A. In closure set of C, we have C, A and B, and C also from dependency C determines B and C determines D. Also from AD determines C dependency, we get C, but C is already included, so we are not writing it again. Now without C determines A dependency, if we find closure set of C, we get C, B, D and A. Here we get A from dependency B determines A, which are same as above, so we exclude dependency C determines A. Now take C determines B. Find the closure set of C. We get C, B. D from C determines D dependency and A from B determines A dependency. Now without C determines B dependency, if we find closure set of C, we get C and D. which is not same as above. So we cannot exclude C determines B dependency. Now, next one is C determines D dependency. In the closure set of C, we get C, D, B and A. B from C determines B dependency and A from B determines A dependency. Without C determines D dependency, we get C, B, A in closure set of C. Now, excluding redundant dependency, we get following dependencies which are B determines A, AD determines C, C determines B, C determines D. There is no any redundant dependency in the right hand side of dependency. As per our discussion, we cannot decompose relation from the left hand side. So now check whether any dependency is redundant or not. For that, we have to check AD determines C dependency, because without that dependency, we can see that there is no any left hand side attribute that is redundant. Take dependency AD determines C. Find the closure set of AD. We get A, D, C and B. Now exclude D from AD and find closure set of A. We get A only, which is not redundant. So D cannot be excluded. Now exclude A from AD and find the closure set of D. We get D only, which is not redundant. So A cannot be excluded. We can say that there is no redundancy in AD determine C dependency. Now composite the dependencies and we get B determines A, AD determines C, C determines BD, which are not redundant. So we have an attribute set F, which is minimal form of dependency. It is not only a minimal form. We get more than one minimal form for the same set of dependencies, which is dependent on the method which is used to find the minimal form. But F we got is not further redundant. There are some important questions available for this tutorial. Let's see them one by one. First one is, what is redundant functional dependencies? Next question is, write steps to remove redundant functional dependency. And the last one is, remove redundant functional dependencies from the following set of functional dependencies, which are A determines BC, B determines C, A determines B, AB determines C, AC determines D. You can write your answers into the comment section. We have seen redundant functional dependency in this tutorial. If you have any doubt or query regarding this tutorial, then you can write into the comment section. If you want to watch another tutorials of this series, the link is available in the description box. If you like the video, then press on the like button and share the video. Stay tuned with us for watching new videos of this series. Thank you for watching this video.